values, different values, but same, manner will be same. Numerical problem, nodal analysis, KCL. Find the current through each resistance. There are 3 resistances. What is the current flowing in 2.5, 3.5 and 5 ohm resistance? We have to calculate by using nodal analysis. Nodal analysis represents KCL. Kirchoff current law is also called as node analysis. How many nodes? 2 nodes. How many nodes? 1, 2, 3, 4. 4 nodes are there in this circuit, and 2 current sources, 6 amps and 2 amps. 2 current sources are there. Is it right? 2 amps and 6 amps. First, we have to identify how many nodes are there in this given circuit. There are 2 nodes. These are the 2 nodes, and total 4 nodes are there. But we have to assume this as ground or F. If you consider these nodes as 1, 2, this must be grounded. Instead of grounding anyone we have to ground. Now it is V1 or VA, voltage at node point A, VA or VB. Or you can consider node 1, V1, V2. The name what you are taking, that may be different values also. Node 1, N1, N2 also you can take. But potential at node A and node B, if you calculate, you can calculate current through 2.5 ohms resistance. Because potential by resistance gives current through 2.5 ohms resistance. If you know the potential at between 2 points, then you can know how to calculate this. I equal to V by R. 2.5 ohms, what is the current flowing, you can calculate. Okay. First of all, we identified the number of nodes because this is a nodal analysis. Kirchoff current law we are applying. Now, before applying Kirchoff current law, entering current. What is the current entering in this branch is 2 amps. 2 amps. Let us say I1 is the current entering. Entering current will be taken as negative. For ours, we are assumed that for KCL we assume that entering current negative, whereas leaving currents positive we assume. Now the current entering 2 amps current entering in this branch up to VA at this node, the entering current is I1. The remaining current I2 and I3 are leaving, assuming that. Whatever the direction you can consider. If you consider all are entering, then we have to consider all are negative. If you consider 2 currents are leaving, 1 current is entering. You can consider whatever it is. The sign direction, if you made entering to the junction point or node point A, you can consider negative. Suppose you mentioned that it is I3 is like in this direction and I2 also in this direction. Suppose if you mention, then what we have to write? Minus I1, minus I3, minus I2 equal to 0. But we assume that current direction is in this direction. Previous problem also we assumed same direction, I2, I3. Coming to node point A. Now we are applying KCL at node point A, at VA. How to apply KCL at node point? By considering entering current is negative and positive current leaving. Leaving currents will be positive. These 2 currents are leaving, assuming that. According to the directions what you marked on your paper or on your circuit, that is important. Okay. I1 is the current entering, minus I1 plus I1. And leaving currents are I2 plus I3. That will equal to 0. The Kirchoff current law says that the algebraic sum of total current entering at a node point equal to 0. Total currents. The total currents all must be equal to 0. Or sum of incoming current equal to outgoing currents. Sum of incoming current equal to outgoing currents. I1 equal to I2 plus I3. That also you can apply this. If you consider I1 is the entering current and 2 currents are leaving at this point VA, this is I2 and I3. If you consider total current becomes 0, or we can say Kirchoff current law is sum of incoming current equal to outgoing current. Sum of the incoming current, only one current is there. I1 equal to I2 plus I3. You can write. I1 equal to I2 plus I3. You can write. Now if you send to this side, I1 minus I2 minus I3 is equal to 0. If you send that side. And if you made common minus, plus, you can write that equal to minus I1 plus I2 plus I3 equal to 0. If you send minus to this side, same equation will get. Sum of incoming current equal to outgoing currents. This is the incoming current. I1 is the incoming current. Outgoing currents are I2 plus I3. What is the definition of KCL? Incoming current equal to outgoing current. The sum, algebraic sum of incoming current equal to algebraic sum of outgoing current. I1 equal to I2 plus I3 you can write, or else you can, if you send this side, I1 plus I2, I1 minus I2 minus I3. Okay, previously it is minus. Now we made minus is a common. Minus I1 plus I2 plus I3 equal to 0. If you send minus to this side, nothing will happen. Again same equation will get. That's why we assume that entering current taken as negative, positive, leaving currents may be positive. You can consider entering current may be positive, leaving current may be negative. But one thing we have to remember, when you consider entire circuit, we have to follow the same. Entire circuit we have to follow the same rule. Okay. In the previous problem, we assumed that this one. Okay. Now I1 minus I2 plus I3 equal to 0. Now we have to write according to Ohm's law, V equal to IR. From that I equal to V by R. I equal to potential divided by resistance. Now I1 already we know 2 amps. Minus 2 plus I2 is the current entering in 2.5 ohms resistance. The 2.5 ohms resistance is in between VA minus VB. You have to consider, because the current entering in this direction, that means VA to VB it is flowing. Current always passes from higher potential to lower potential. We have to make difference VA minus VB. Why we are considering I2 in this direction? We consider now which is higher potential. VA is the higher potential, because higher potential to lower potential the current always passes. The current always enters from higher potential to lower potential. That means VA minus VB by 2. The resistance 2.5 plus I3 is the current flowing in 3.5 ohm resistance. Now what is the current? I3 can be replaced by V by R. Potential between two terminals and its resistance. That is Ohm's law. VA minus 0 by 3.5. That equal to 0. That equal to 0. We can write like that. Now minus 2 plus VA by 2.5 minus VB by 2.5 plus VA by 3.5 plus minus 0 by 3.5, nothing will happen. It is 0. We can write like this. Now the equation 1 we can write as VA and VB. Set this minus 2 to this side, RHS side. Send minus 2 to RHS side. That is 1 by 2.5 into VA minus VA, 2 terms are there. 1.2, 1 by 2.5, 1 by 3.5. We made common plus 1 by 3.5 into VA minus 1 by 2.5, 1 by 2.5 into VB. We can write like this. VB equal to, send this minus 2 to this side, it becomes 2. It is the equation 1. These are the coefficient of VA and these are the coefficient of VB. Now similarly we are applying KCL at node B. Apply KCL at node B. Apply KCL at node B. Node B or node 2. It is node 2. Assume that this is node 2, this is node 1, or A node, B node. We can assume node 2 or node B. Whatever the name convention you take them, that we have to follow in the circuit. Now apply KCL at node B. Now the current entering is this one, 6 amps. Assume that it is I4. Whatever you can consider, you can consider I6 also this one. Okay, the name is different, but answer must be same. I4 and entering current is I4. 8 as 6 amps is flowing in this side, anti-clockwise direction, and some current will flow, but I2 always comes here. You can consider I2 coming up to this point, node point, I2. And some current will flow in this direction, that is I2 plus I4 current will flow. I2 plus I4, if you according to the directions, what you mark, this is I4, I5, assume that I5 is the current flowing in 5 ohms resistance. Now this current will come up to this junction, up to this node point. Okay. Now apply KCL at node B or node 2, then entering current is minus I4, and leaving currents are positive. We consider it is entering current or not? I2. It is entering current. I2 is coming to this side, 2.5 ohm resistance. After that, it is entering current again. I4 minus I2 plus leaving current is only I5. Leaving current I5 equal to 0. We applied for node B. Okay, two currents. Entering currents are 2. Leaving current is only 1. We can apply like this also. I4 is already we know I4 6 amps minus 6. I2 is the current flowing in 2.5 ohms resistance. 2.5 ohms resistance. If you not consider this I4, I2, if you consider this I6, we have to consider VB minus VA. Instead of that, you can consider like this also, I2. Now, if you consider I2 is flowing in this direction, we have to consider VA minus VB. VA minus VB by, what is the resistance? 2.5 plus I5. I5 is the current flowing in 5 ohms resistance. What is the potential? VB and 0. It is a 0 volts. It is also 0 volts. It means it has 0 potential. Okay. Now VB by 5 equal to 0. Now make the another equation. Form the another equation. This is minus 6 minus VA by 2.5 minus, it is minus, okay, put in bracket, then it becomes plus VB by 2.5 plus VB by 5 equal to 0. Carefully we have to remove the bracket or use the brackets. It is minus I2, I2 is VA minus VB by 2.5 plus VB by 5 equal to 0. Now put the equation similar to equation 1, because VA plus VB equal to 2, like that. Minus 6 if you send to that side, or you can consider minus 1 by 2.5 into VA minus 1 by 2.5 into VA plus 1 by 2.5 plus 1 by 5 into VB equal to, send this side, it is 6. This is the equation number 2. If you obtain the equation, Cramer's method, carefully if you do, then you can get VA, VB unknown values. Okay, now write the equations 1 and 2. Assume that it is the equation number 2. Assume that it is the equation number 2. Now write the two equations in one side, or equation number 2 it is. After that we have to convert into matrix form. After that we have to do Cramer's method. Okay, write the equations side by side or up and down. Okay, now we are writing the equation number 2 here, or we can write in matrix form. What is the matrix we can obtain? Do that Cramer's method. Follow that Cramer's method. Write the equations in matrix form. This is the matrix is directly, I am erasing this. The equation is this one and this one. Equation 1 and 2. Okay. Equation 1 and 2. Now we are writing the matrix. The coefficients of V and VB and coefficients and constants. These are. Now 1 by 2.5 plus 1 by 3.5. What is the value you can represent? Or else directly you can write. Okay. 1 by 2.5 plus 1 by 3.5. It is minus 1 by 2.5. This is minus 1 by 2.5 and B coefficient 1 by 2.5 plus 1 by 5. Now coefficients we written. Now B and BB are now 1 by 3.5. This is the matrix of 1 and 2, 6. 2, 6 is the constants. Now convert matrix form we converted. We have to find out determinants. Delta 1, delta 2. And do that problem. Delta becomes how much? Delta equal to
0.
Determinant of this one. Determinant of this one. What is the value? Find out. Delta
0.6857.
This AD into AD minus BC we have to do. Assume that AB, CD is AD minus BC. 1 by 2.5 plus 1 by 3.5 into, we have to multiply again this one, 1 by 2.5 plus 1 by 5 minus BC. Minus 1 by 2.5 into minus 1 by 2.5. Okay, answer is delta equal to, calculate the delta
0.6857.
0.6857 delta. Have you got this answer or not? Delta value.
Wrong, sir. 1 by 2.5 plus 1 by 1 by 4.
0.6857 minus
0.68 into 0.6856. So 0.68. Hey, you are చెప్పేది రా.
Calculate delta 1. Delta 1 is we have to replace this one with 2 6. 2 6 and same again minus 1 by 2.5. 1 by 2.5 plus 1 by 5. Find out the determinant. Find out determinant of this. Calculate it. 1. We have to use brackets in calculator to get answer. If you directly multiply, you won't get answer. Okay, 3.6. Now find out delta 2. Delta 2 we have to replace this column with constants. This must become here and it will be continued. Delta 2. Find out delta 2. Delta value is delta 2 is
2 6 minus 1 by 2. Sir, 1 by 2.5 plus 1 by 3.5
1 by 3.5
minus 1 by 2.5.
Find out this answer.
Teja. Naina.
Minus.
It's a 4.114.
114.
Something
Sir,
Answer. Final answer.
yes, sir.
Again.
నాకు అవసరమే లేదు.
Delta
9.1
నేను చెప్పింది
4.1 మనం చెప్పింది అదే రైట్.
Now the answer is 4.914.
914.
Determinant 2 answer is this one. Now Now find out VA equal to delta 1 by delta.
Delta ఏంది?
Equal to delta F by delta.
Delta.
Delta 1 is 3.6.
Sir, delta is wrong, sir.
Delta is
Wrong, sir. అది.
ఈ నోట్స్ మధ్యలో చేసింటే మొత్తం అనుకుంటా
silence. Delta is 0.4.
11.
Now value is delta 2. Again you substitute delta 2. 4.914. 4.914 divided by 0.414.
Yes, sir. First దానికి చెప్పు.
VA
First దానికి. Delta 1 equals to 8.710.
695 volts. VA
7 వచ్చింది సార్.
VB
VT delta 2
4.914 divided by 0.414. 944 volts.
ఇంతేనా 3
Okay, now we calculated node voltage.
అది అయిపోయింది ఇంకేం అవసరం లేదు.
Now we can
తప్పురా
calculate find the current
పోతే
through
పోనీ
each resistance.
వాళ్ళు బాధ వాళ్ళు కొడతారు 8 కరెక్ట్గా వచ్చింది కదా
సార్ ఫస్ట్ వన్ 8.750
8.750 సార్
7506
06
volts.
ఎస్ సార్
VA.
వాళ్ళకి రాలేదు ఈ పాపము
Correct? 11.97.
జస్ట్ వెయిట్ సార్
ఎందులో
4.914
914 మళ్ళా
Okay, VA will be
by
calculated.
by 0.4114
0.4114
11.955 కరెక్ట్ సార్
ఎస్ సార్
Now, what they given? Find the current flow each resistance.
Yes.
Now, first find out current flow 3.5, current flow 2.5.
V2
current
minus
flow
V1.
5 ohm. Okay. Now, current flow 3.5. I 3.5 ohm equal to, or you can write current flow 3.5 ohms equal to I 3.5 equal to VA by VA minus 0 by 3.5 because this is 0 potential.
VA
Current flow VA is already calculated.
8.7506
by
3.5 0
Now tell the answer. VA. Which is bigger? If you got V
by
is bigger,
3.5
we have to
3.5
take the difference V
delete
minus
ಕೊಟ್ಟು
VA.
ಊರಿಕೆ delete ಕೊಟ್ಟು
Because current always passes from higher potential to lower potential. If you got the answer, V is higher value,
506
then current direction will be different.
divided by
VB
3.5.
we have to consider. The answer is
3.5
VB
నువ్వు
minus
కొట్టరప్ప
VA by
మనకి తెలిసేది లేదు ఏమీ
2.5.
లేదు
You will get some answer. That is the current. VB minus VA, VB is for 11.944 minus VA is 8.7506 by 2.5.
11.944
Equal to some answer you get. Now current through 5 ohm.
minus
Current through 5 ohm equal to I 5 ohms equal to VB
8.7506
by
75
VB minus 0
7
VB
balla,
minus
7
0
balla.
potential difference across 5 ohms divided by its resistance 5.
7506.
That gives VB is already calculated
Divided by
9444 divided by
2.5.
5. You will get amperes. All are amperes. This is also ampere. This is also ampere.
8.5
Like this method you have to follow whatever the given the problem, but the values are changed. Same problem you can do homework.
8.5